Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. In the lecture series of Material Studio and within the course of hydrogen storage, we are at the lecture number 4, and in today's lecture I will explain optical properties of material. Their physical meaning, their importance in modern research, and how we can calculate them using CASTEP code of Material Studio. So optical properties describe how a material interact with light, and when light fall on a material, it can be observed, reflected, or transmitted, and all of these behavior depend mainly on the electronic structure of the material. In simple terms, optical properties tell us how a material responds to electromagnetic radiation, especially light, and this response is directly controlled by how electrons are arranged and how they move inside the material. From a research point of view, optical properties are very important because they are strongly connected with many advanced applications. And an optoelectronic device such as solar cell, LEDs, photodetector, optical property determine how efficiently a material absorb light and convert it into electrical signal. If a material has strong absorption in the visible region, it is generally a good candidate for solar energy harvesting and photodetector application. And in photocatalysis, optical absorption is very important because it controls the generation of electron-hole pair, which driven reactions like water splitting and hydrogen production. Better absorption mean higher photocatalytic efficiency. And in hydrogen storage research, optical properties are not directly related to storage capacity, uh, but uh, but they help us understand a change in electronic structure during hydrogen adsorption. So these changes can indicate bonding behavior, defect formation, and charge redistribution. So optical analysis becomes a useful and direct tool to study hydrogen storage. To study hydrogen interaction and material modification. In sensing application, changes in optical response after gas adsorption can also be used for detection. Now coming to the main optical properties, is optical absorption tell us how much light a material can absorb at different energy. It is very important. It is very important for solar cell and photocatalysis because higher absorption lead to better light harvesting and more charge carrier generation. And same like optical conductivity describe how easily photogenerated electron can move through the material. Higher optical conductivities a higher optical conductivity improve charge transfer, reduce recombination, and enhance performance in both optoelectronic and photocatalytic system. Same reflectivity tell us. If you see here, same in the case, reflectivity tell us how much light is reflected from the surface. And for solar cell application, low reflectivity is preferred because we want maximum light absorption, while high reflectivity is useful in optical coating uh, and a reflective device. Also the dielectric function. The dielectric function is the most fundamental quantity because it describes the overall response of a material to light, and all other optical property are derived from it. So it's play a key role in determining light absorption, electronic excitation, and overall optical behavior of the material in all these applications. Now moving ahead toward the practical part, how to calculate these optical properties in K-step code of Material Studio. As you can see on the screen, as I mentioned in my first lecture, that the first and most important step is structure optimization because the structure must be fully relaxed and at its lowest energy state. After that, we are able to calculate the other properties like band structure, density of state, and optical properties are. For example, if we even do the calculate the vibrational analysis, phonon dispersion, phonon dust. In this case, also at first we will must do the geometry optimization. And geometry optimization is we already take class on geometry optimization. So we will set some basic parameter which include exchange correlation function, and usually we set GGA PBE, and a suitable cutoff energy and a dense K point grade, because optical calculation required high accuracy. After that, we enable optical properties and select output. So as you can see on the screen, the I already geometrically optimize one structure. So I will show how to move towards the properties calculation. So from the task section, you must select properties. Since we are calculating optical properties, so from the task section, we will change geometric optimization to properties. And as I mentioned, that no need to change anything else. And electronic properties, and I mean an electronic section, electronic tape, as we use 250 electron volt cutoff energy with the 2K point, and with ultra soft pseudo potential. So we will must go with the same parameter, no need to change anything else. So just from here, from property section, we will change the optical properties. And if for example, if you want to change the energy range or K point set for specifically for up to for optical properties, you may select change from here, and then run the calculation. And once the calculation is completed, it will take just few minutes, from few minutes to few hour, depend on machine and um, the system under consideration. So after that, we will open the output file of CASTEP. I mean output file of CASTEP, which we perform calculation for optical properties, and then open the CASTEP button. Here, select analysis, and in analysis section, you will see optical properties. So it's mean we calculate optical reflectivity, optical absorption, optical refractive index, dielectric function, conductivity, and loss function in one file. So no need to calculate, I mean to run the separate calculation for optical absorption or conductivity or refractive index. We will get all these graph from this one file. So how to analyze from the function? You should select reflectivity, and in the unit section we have three options: EV, CM, and NM. But mostly we are go with the nanometer. So click on calculate, and here after they click on view, so you will get the graph of reflectivity. And by applying the same procedure, we will get optical absorption. So just select absorption from the function section, and from the unit section, no need to change. uh, Nanometer is still fine, and then calculate, click on calculate. After that, click on view, so you will get absorption. Same in that case, select the conductivity, and click on calculate, and then view. So that's all. If anyone have any question, please feel free to ask.